Watch this video if you want to quickly practice an A-level maths question.
So I think this is one of those questions that looks a little bit scarier when you first look at it, but when you break it down, it's simple. You just need to understand the geometry a bit. So we've got two straight lines and a line with that equation y equals 8x minus x to the power of 5 over 2. And then they all kind of intersect at the point at the top, and you need to find the area. So all we have to do first is prove that a is 4, which is pretty easy. We just sub it in. And then now we have to find the gradient of that first line where we differentiate that y equals 8x minus x to 5 over 2 to find the gradient. And then we sub everything in. So once we find that, we can find the full equation of line 1, and it enables us to solve the rest of the question. So we find c is 48, which that goes straight in if you look. So 12x plus y equals 48, which is perfect. So the last part is to find that area R. So if we find the intersection, we can find the full area. So if you just kind of watch this diagram, we're going to break it into two right angle triangles between L2 and L1. And then we're going to find the full area, and then we're going to integrate that curvy line. And then we're going to subtract the full area from that to find the blue area that I'll kind of just shaded in there. So yeah, as you can see. So now we need to equate them to find the intersection point. So we need to equate two straight lines, sorry. So we're going to find the x and y coordinate, and then we're going to be able to use a half BH, which is the area of a right angle triangle, to find each area, add them up. So we found that the y coordinate is 19.2, the x coordinate is 2.4. So now we're going to use the right hand triangle area formula. So yeah, this is what we're doing. It comes to 38.4. And now the last thing to do is we had that curvy equation. So we differentiate it first, now we're integrating it. And most of these questions, right, you're just gonna have to integrate like the one that looks a little like scarier. But this is nothing crazy. This is just you raise power, divide through by the raised power, or times by 1 over that new raised power, which I did there, times by 2 over 7. And it's between 4 and 0. So the 0, because there's an x in both terms, it just zeroes out. So we just have to sub in 4, and we end up getting, it was like 27.4. And then we subtract them. So we subtract the full area from the area under the curve, and we end up getting 11. Nice.